For this sample problem, we are going to be looking at the concrete foundation system for Plan 100. So we are going to look at different components of the foundation system, including the drain tile, the waterproofing, as well as the concrete itself, which includes the floor slab and the vapor barrier, as well as the non-settling fill underneath. The second portion will get specifically into the concrete itself for the slab, the footings under the post, the foundation walls, the footings, and then totaling up for the entire project. So before we actually get to the concrete part, we'll focus on the first part to gather up the information we need to actually calculate what the concrete is. So some of this will be a little bit of a review, but for the most part, it will be some new information. So starting off, we are going to look at the exterior perimeter of the foundation system. Something we have calculated many times before, but as a review, it is the 2 times the 36-foot length plus the 2 times the 26-foot 4 width for 124 feet 8 inches as our perimeter. So keep in mind, we are back to the foundation, so we do have the brick ledge to contend with. We want to make sure that we are looking at the 26-foot 4 width, not the 26-foot that is the framing dimension of the floor plan. For number 2, we're looking at calculating the centerline length of the front foundation wall. So again, a little bit of review on centerline. We have our 36-foot length. We need to subtract out half of each of the side walls in order to get to the center line. You can always review the drawings that are posted relating to the excavation to help you calculate your center line. 35 feet 4 inches is the center line length of our foundation. And number 3, we're looking at the back and sides of our foundation. So we're kind of lumping a couple dimensions and calculations together in this question. So we have our side length that is 26-foot 4. Remember, we have to subtract out half the front. The front wall is actually 12 inches thick, not 8 inches. The back wall is 8 inches thick, just like the sides. And we get 25 foot 6 inches. The back is going to be the same as the front. Simply because they are different thicknesses does not mean that they are different lengths. So the back is going to be the same as the front at 35-foot 4. So if we have 2 times the sides plus the back, because we have 2 sides, then we have 2 times our 25-foot 6 plus the 35-foot 4 inches, and we come up with 86-foot 4 inches. Occasionally we'll need to know the full centerline perimeter. So that is simply 2 times the front times 2 times the sides, or we can take the front that we just calculated, number 2, add to the back and sides that we just calculated in number 3, and get 121 foot 8 inches. If you wanted to calculate it standard like we did in number 1, that is acceptable too. You should come up with the same answer. If you don't, then you will see that you've done an error somewhere in your calculations. For number 5, we are looking at the area of damp proofing. So this is a surface area. This is a vertical area on our foundation walls. So it is going to be our exterior perimeter. It's not centerline because the damp proofing or waterproofing goes on the exterior of our foundation system. So that is the 124 foot 8 inches. We need to calculate the height. The height is not going to be the full height of our foundation system, which is 8 feet. Remember, per our section drawing, we see that our finish grade is held 8 inches below the top of the foundation wall. Our damp proofing will only go up to that level. It will not go higher. Typically this is done to more of an aesthetic reason. We don't want to have that tar all the way up, especially if we put foam on the outside of that. We're not going to carry our exterior material down to finish grade, so it's better to just leave the finish of the concrete rather than the damp proofing. So we need to subtract the 8 inches. So that is top of wall to grade. And we get a height of 7'4" So for our surface area, if we take our 124'8" and multiply it by our 7'4", we end up with 914.22, or roughly 915 square feet. So that is where all of our damp proofing for our exterior foundation will occur. For number 6, we are looking at the drain tile that is around our perimeter. If we look back at our wall section, this is the drain tile we were talking about. It runs along the exterior foundation wall right on top of our footer. So this helps with any drainage that comes down our foundation wall collected from the damp proofing. It's not letting it go through the foundation wall, so it needs to go somewhere. Gravity takes it down, goes into our drain tile, and helps disperse the water. So as we see, it goes around our foundation system on top of our footer. So it is simply going to be the same as our exterior perimeter. Which is 124'8". Moving on to some dimensions that can help us with our calculations for concrete. We are now looking at the width of the concrete floor slab. So if we have our foundation wall with our footer underneath, per the drawings, our foundation slab sits on top of our footer and butts up to the inside of our foundation wall. And it carries over to the other side as well. So if we're looking at the width of our slab, we start off with the width of our foundation, our 26'4". And we know we have 2 different wall thicknesses. On the front, we have our 12-inch wall thickness. The back is 8-inch thickness. We need to get rid of both of those thicknesses. Instead of coming halfway like we do for our center line, we need to go the full 12 inches for the front wall and the full 8 inches for the back wall, giving us a 24'8" width for our concrete floor slab. Number 8 then is looking at the length. So same concept. It just sits on the top of the footer for each of the sides if we're dealing with the length. So for our length, we start off with our 36-foot length. We subtract out the full 8 inches for one side, the full 8 inches for the other side, giving us a total of 34'8". Number 9 then looks at the vinyl barrier. So we can see for the polyvinyl vapor barrier, it goes underneath the slab. It's sitting on top of the non-settling fill that is then below our slab. So where this is located goes the full length underneath our floor slab. So if we're looking for a square footage, we just calculated the width of our slab and the length of our slab. And since our polyvinyl barrier runs underneath our slab, we can simply take our length times our width of our floor slab, and we get 855.111, or roughly 856 square feet for our actual square footage of our vinyl barrier. Number 10, we are now looking at the non-settling fill. So if we look at our drawing again, we've got our foundation wall, we've got our footer that is underneath, we have our slab. The non-settling fill is underneath our slab. So we need to figure out what the inside of this footer dimension is in relation to the numbers we already know in order to calculate what that width and that length is for our non-settling fill. So we're starting off with our width. So if, for example, we have a 12-inch thick front wall, we also know that we have a 24-inch thick footer. We can figure out that we have a dimension on each side of our foundation wall, and that is going to be the same dimension because our foundation wall needs to sit on the center of our footer. Otherwise, we can have an unequal distribution of the load and it could cause our footer to fail. So they need to be the same dimension. So if we take our footer width, subtract out the portion that the wall sits on, we see that we have 12 inches. It happens to be the same as the wall thickness. It does not always have to be the case. So now that we've gotten rid of the 12, what's left will be split between the two sides since it must be equal. So 12 inches divided by 2 gives us 6 inches. So in this case, 6 inches is on either side of our foundation wall. So therefore we need to come 6 inches in from the inside of our foundation wall. We just determined that we have a width on inside of our foundation wall of 24 foot 8 inches. We need to subtract the front, which is 6 inches, and we also need to subtract our back. It's the same calculation to get to 4 inches. Instead of 24, we have 16. So we have a 16-inch back and side footer. We have an 8-inch wall. We're left with 8 inches. Divided by 2 gives us 4 inches. That is where we see our 4 inches. So the width then for the inside of our footer is going to be 23 foot 10 inches. Next up, for number 11, we're looking at the length. So the length, and again this is inside our footer, same as number 10. We're looking at a 34 foot 8. So this was our inside foundation wall number. Inside wall. We subtract out the full 4 inches for the side because that was an 8-inch foundation wall with a 16-inch footer, and another 4 inches for the other side, again 8-inch wall with 16-inch footer width. So we get a total of 34 feet for our length. For number 12, we're looking at the square footage of concrete footings underneath our adjustable posts. If we look at our foundation system, we're talking about these 3 footing pads underneath. So we have 24 by 24 by 12 for each one of these footing pads. If we're trying to figure out what our non-settling fill is going to be, these 3 will not have non-settling fill underneath them. They will be on solid ground, so we need to make sure that we remove them. That is why we're trying to do this calculation, in addition to eventually figuring out what our square footage, or cubic yardage of concrete is going to be. So if we have a 24 by 24 by 12, typically what you'll have is a square footer. So that would be the 24 by 24. The 12 inches is the height. So the square footage for one pad is going to be 24 inches by 24 inches. Or you can write it in feet, 2 feet by 2 feet, and end up with 4 square feet. We have 3 pads that are all the same size, so a total of 12 square feet is our square footage of concrete footings underneath our adjustable posts. For the last one, for the first problem set, we are looking at the cubic yards of non-settling fill. So as we just determined, we have our foundation system, we have our 3 footing pads that are underneath our posts. The rest of this area then has non-settling fill underneath it. So we need to figure out what that cubic yardage is. So first off, we need to figure out what that square footage is. So we calculated inside footer width and length. That was our 23 foot 10, as well as the 34 from number 10 and number 11. So we have 23 foot 10 inches for our width. We have 34 feet for our length. If we multiply that together, we can then subtract out the square footage that is these footing pads. These areas will not be included in our non-settling fill, so we need to get rid of that. We end up with a total of 798.3 repeating square feet. But what the question is asking for is cubic yardage. So we need to take our square feet and we need to convert it into a cubic foot before we do cubic yardage. So if we look at our plans, we see we have 4 inches of non-settling fill. That is our height. So 4 inches is our height. We multiply that by the square footage we just obtained. And we end up with 266.1 repeating cubic feet. Converting that into cubic yards means we need to divide by our 27 cubic feet per cubic yard, and we end up with 9.856, or I said 9.86 cubic yards. If you rounded it up to 10 cubic yards, that would be perfectly acceptable as well. So all of the components we just figured were all of the additional materials and dimensions we need for our concrete foundation system without even starting to calculate the concrete itself. We start off by putting our non-settling fill down, then we put our vapor barrier on top of that before we actually pour our concrete slab. So we need to know all of these dimensions and we need to know all these materials before we can actually move on to our concrete. But that concludes the first problem set.